Okay, 9b part 2 is a continuation. It's asking about the magnitude of the action and reaction forces between the boxes. So again, let's draw that picture that we had for the last scenario. We have our smaller block A and our larger block B. This has a mass of 60 kilograms and this has a mass of 90 kilograms. And it's asking us to find the action-reaction forces between A and B. And so really what it's asking us is to find the force that A puts on B and also the force that B puts on A. And remember, due to Newton's third law, those forces are going to be exactly the same. So let's draw our free body diagrams for this situation. This is going to be block A. We have our applied force, which is the 600 newtons, our force of gravity, our normal force, our force of kinetic friction, and then also this reaction force, which I'm going to write FB, A. And so what I mean by that is the force that block B is putting on block A. Now let's draw our second free body diagram, this time for block B. We have our force of gravity. It's a different mass than this block, so these forces are not exactly the same. We have our normal force. We have a force of kinetic friction, which is opposing the velocity, which is to the right. And then we have the force that A puts on B. And so, due to Newton's third law, we know that the force that A puts on B is the exact same as the force that B puts on A. Right? They're equal and opposite forces. Okay? And so now what we're going to do is, look at either of these two situations in order to calculate this force AB, or this force BA. And just quickly looking at these scenarios, it looks like it's going to be easier to solve on block B because we just have one less force, right? In this case, we have an applied force, but in principle, using either of these blocks will work. So let's start looking at block B. Our goal is to find our FAB, and so let's start with the sum of the forces statement. We know that the net force is going to be equal to FAB plus the force of kinetic friction plus the force of gravity plus the normal force. And as usual, these two are equal and opposite, and so they cancel. And so we're left with the net force is equal to the force that A puts on B plus the force of kinetic friction. Now we can break this down symbolically, right? Because we know that the net force is going to be equal to the mass times the acceleration, right? So this is going to be equal to ma due to Newton's second law. This is what we're looking for, right? We're looking for the force that A puts on B. So that's our final goal. And what we can also do is rewrite out our force of kinetic friction in symbols as well. And so we're going to put a negative because east is positive and our force of kinetic friction is in the opposite direction. And so this is going to be equal to minus mu k mg. And so now we can put some numbers in. So our mass is 90 kilograms for block B. Our acceleration, which we calculated in the previous problem, is 2 meters per second squared. Our FAB, we're not going to rewrite. And our mu k is 0.20. Our mass is 90. And G is 9.81. And so what we're left with is 180 plus $176.58 is going to be equal to the force that A puts on B. And put that into our calculator, and we get 356.58 newtons. And so to round that, the magnitude of the force is 360 newtons. Right, and that's going to be exactly the same. Let's get rid of this vector symbol actually. That's going to be exactly the same as the magnitude that the force of B puts on A.